Find the arc length of 2 times x to the 3/2 power plus 1, where x is from 0 to 1. Let me show you the graph. See, y equals to x will be a straight line. Y equals to x squared will be bent like that. But if you have y equals x to the 1.5 power, it will be bent somewhere in between. Then you take this one and you elongate it because you have times 2. And you add 1, so it's going to be elongated and you shift it up. So the result is that you have a graph that looks like a very thin parabola. Okay? And we're looking at the portion from 0 to 1. So we have this curve and we're trying to find this arc length. How do you do that? Well, solution. Anything is sum of its parts. The universal formula for solving any problem with an integration. Okay. To find any quantity, it's sum of its parts. And then the idea is that these small ds's are very fine pieces of the length s, so that when you zoom one of these in, you have ds here, dx here, dy there. So there's a relationship between infinitesimals dx, dy, and ds. It's the Pythagorean theorem. And ds would be dx squared plus dy squared, and all this inside the square root. Now, such an integral cannot be done. We only know how to do the integral if it has dx or dy there. So we would just divide this by dx, and we multiply by dx. And that's going to allow us to do the integral, right? And we actually did this calculation before. We simplified this, and we found out that if you bring this dx inside, this becomes squared, and you have dx squared over dx squared. What's that? 1. And then dy squared over dx squared, that's dy over dx, right? So it's dy over dx squared. And because x in this given, you have x between 0 to 1, so that will be the bounds for this integral, 0 to 1. And that's what we have to calculate. Now, what's the meaning of dy over dx? That means you're differentiating this, right? Dy over dx is the Leibniz notation of differentiating this. So we're going to differentiate this where the power rule says this comes down. So it's 2 times 3 over 2. And you have to subtract 1, right? So what is that? 1/2 power, right? What's the derivative of 1? 0. Simplify by canceling the 2 and 2 there, and you get 3 times square root of x. 1/2 power is square root, right? Okay, so that means I can plug that in here and get integral from 0 to 1, square root of 1 plus 3 squared is 9. What do you get if you square root of x?
Pops out.
You just cancels the square root and you just get x, right? So that's what we have to do. Rewrite the square root as 1/2 power, and I'm going to switch places here, so it's 9x plus 1 to the 1/2 power dx. And I'm going to use the fact that integral of f of ax plus b dx introduces the reciprocal of a, right? 1 over a, and then you integrate as if ax plus b was just a simple x. So we're using this shortcut over here. So what does this 9 introduce?
1 over 9.
1 over 9 will be introduced in front, right? And then you treat this like x, And we know how to integrate x to the 1/2 power, right? We add 1 to the exponent, which will be 3 over 2. And what goes in front?
2 over 3.
2 over 3. Now you plug in 1 and 0 there. Now multiplication, top to top, bottom to bottom, you get 2 over 27. And when you plug in 1, you get 10. So you get 10 to the 3/2. When you plug in 0, you get 1. So 1 to the 3/2, that's just 1. 1 to any power is 1. So that's the answer.